Welcome. I'm going to do a video on checking to see whether or not your data is normally distributed. We talk a lot about normal distributions, but one of the problems is sometimes we just kind of assume that our data is normally distributed without actually knowing if it is or is not. So what I did was I took three different groups, Group A, Group B, and Group C, and I'm going to go through some ways to double check to see if our data is in fact normally distributed. And one of the things that you should do is you should use your understanding um, of stats and the graphs that you've been studying to check. And here's how you can do it. And I'm going to show you two different ways. Technically three. You could just plug all this into a spreadsheet and then look at your spreadsheets. And to do that, you would select a group of data, and then you'd go to Insert, and here you could insert a histogram or a box and whisker. Um, Not everybody has Excel, so I'm going to show you how to do this with your graphing calculator, and then I'm going to show you how to do it with GeoGebra. So here's Group A, and so what I've done was I'm going to take a look at a histogram, and in order for a one of the main tellers is whether or not your data is normally distributed is if your histogram is symmetric. So what I did was I took my data from Group A and I plugged it all into my list 1. If you take a look, 35, 35, 37, it all matches up. What I'm going to do now is this. I'm going to go to stat, and I'm going to go to second and y equals, and I'm going to press on, and I'm going to turn that on, and then I'm going to go down, I'm going to select my histogram, and then I'm going to go down, and it says xlist, and I need to press second and L1 because that's where I stored all my data for group A. So now I'm going to press enter, and I'm going to press graph, and if you'll look, I get something really weird. So that's because my window's not set. So I'm going to go back, I'm going to take a quick look at my data. It looks like I go from about 35 to 57. So I'm going to go window, I'm going to say, well, if it goes from 35 to 57, I'll go from 30 to 60. And I'll go in groups of 5. X scale means how big. I always like to go -1 and go to 10. And I'll do my Y scale, my Y axis on 1, groups of 1. And there we go. Well, this is not very symmetric. This is pretty straight across. So, it is symmetric, but it's not forming, I should say, symmetric in forming the bell shape. All right, so the histogram should be forming the bell shape. That is not. So group A is not approaching the bell shape. So I'm going to say no. If I go back to my graphing calculator, sometimes what you can do is you press second y equals. Sometimes if you want, you could turn on the second graph, and we'll just see if this works. I'm going to go down, and I'm going to pick this one with the little dots. And I'll show you one in a second. And you can see what happened was I have my box and whisker up here, and I'm going to extend my window just a little bit. I'm going to go to 70, and I'll explain why in a minute. And actually, I'll go from 20 to 70, and now I'm going to go to 10. So my range is much greater. That kind of messed things up. But what I'm looking for is whether or not there's any outliers. There are no outliers, so that's fine. So I'm going to go back off this. I'm going to say box and whisker, at least one outlier. No, there was no outlier, so that's good. Wait, yeah, at most there was one outlier, but there was no outliers. And then there's something called the normal quantile. Now, the normal quantile is a little bit hard to explain. And what I am going to do is I'm going to go back to second y equals, and I'm going to turn this graph off, and then I'm going to press enter. I'm going to go up and plot 2. I'm going to turn plot 2 off, and then I'm going to go up to plot 3, and I'll turn plot 3 on. In the normal quantile, and once again I'm in L1, and I'm going to graph. Let's see what it looks like. Well, now once again I have to adjust my window, so I'm going to say -10 to 10 on my y-axis. Maybe I'll go by groups of 2 and graph, and let's see what happens here. I'm going to do that. Okay. Well, I'm going to do one more thing. I like using the zoom box. So I press enter, I go to zoom, press enter. And what I like to do is this. You go above where your graph ends, and you actually make a box around your data. And this is kind of neat. This looks very, very symmetric. And if it is very symmetric, I mean, it looks almost like I could, put a dot here and then it'd be symmetric through a point. If it's symmetric, then it's no good as far as whether or not your data is normally distributed. The normal quantile should be approaching a straight line. All right. I'm now going to look at how to do this on GeoGebra with group B. So if you're not used to GeoGebra, that's fine. Here's a good chance to practice. You go to spreadsheet. You'd assume you go to probability, but that's not true. You go to spreadsheet. What I'm going to do is this. I'm going to highlight my data in group B, just the data. I'm going to press Control and C to copy it. And then I'm going to go into group A, and I'm going to press Control and V, and I copied my data. All right. So now this is all my data in group B. I'm going to highlight. I'm going to click on A, and highlights everything. And then it says column A, I'm going to press Analyze. And voila, I get all of my data is now analyzed. Now you can see I have a histogram here. And if you slide this, it changes the width of the bars. But if you take a look, when it was back here, you can see it's not really bell-shaped. It kind of looks, and they call it skewed. It's skewed to the left because more of my data appears on the left than it does on the right. One of the things I really like about this is if you press this sigma x, sigma stands for sum, it gives you all of the data. And actually, if I press stat and I go to calculate, I do 1 bar is stat, and I press second and 2. I'll get the same data, assuming I haven't made a mistake, which I must have because it's slightly off for group 2. But you can see like it has minimum is 35, quartile 1 is, yeah, I must have made a mistake someplace, but that's fine because you'll see why in a minute. If I want, I can change the type of data I'm looking at by going to this histogram box. Here's a bar chart, which we don't actually want, a box plot, and this is why I would like this, because the box plot shows these two pieces here. These are your outliers, and if you're not sure how to calculate an outlier, well, first of all, this was not symmetric, so it already fails. At most, that 1 outlier. No, it had 2 outliers. So this one, group B, obviously fails automatically. But it's nice because you can see that. And like I said, if you don't remember how to do a box plot, you can easily look it up on one of my other videos. And you can see, if you take a look, this is a dot plot. You can see it's skewed to the left. And here's my normal quantile plot. And you can see the data is stacked on one side and then sparse on the other.
I'm gonna go outside.
You need to get dressed then. So the normal quantile plot is not really on a straight line. You can see it has all these pieces here. It's stacked on one side, it's sparse on the other. So group B would not be a good candidate for seeing if this was normally distributed. So I'm going to take a look at group C. And once again, I'm going to go to GeoGebra. I'm going to put group C here. Possibly. Let's see. Copy it. Oh, there we go. And now I'm going to paste it into B. Actually, you know what? To probably be smarter is let's put group C in group C. And let's put group B. Let's put group B actually in group B. Alright, so now I'm going to analyze my data from group C. And I'm going to say column C, make sure you're in the right column, and analyze. And let's see. And it's kind of neat. If you want, you can do this. And now I can look at two graphs at once, which is really, really cool. You can see my histogram is fairly bell-shaped. Let's see if it looks a little skewed at this point in time. Yeah, that's not inspiring too much confidence, but no. It was fairly bar-shaped. Go with something like, well, you can see that's pretty good. And you can see this is they're not exactly all the same lengths, which is good, but they do look pretty symmetric as well. If I wanted to look at a dot plot, which sometimes helps, you can see that looks pretty good too. It's not great, but it's not bad. It's not an outlier, and that's not an outlier. So far, Group C has passed. Is it symmetric? Yeah, it's fairly symmetric. Does it have any outliers? It doesn't have any outliers, so that's still good. And I'm going to take a look at the normal quantile. And the normal quantile will look something like, it should look like a straight line. And that is pretty much a straight line. Is it symmetric? It's not completely symmetric. It is fairly like a straight line. So we're in good shape, which means if I want to find the actual standard deviation, or if I want to use this, I can say, well, my mean is 50.65. And, oh, that's funny. I was going to say, I thought they had the standard deviation here. Well, although I don't actually see the standard deviation, and I was almost certain that it was on here, that's fine too, and I'll show you why that's fine in 1 second. Because if I go back to here, and I go to Stat, I go to Calc, and I say, alright, well, let's see. For list 3, L3, I put it on. Remember, S of x stands for a sample standard deviation, and sigma x stands for the population standard deviation. And there it is. There's all your data, and like I said, it should match up. 47, I have 51.5, I have 54 and 61. That's it. And once again, if you want to graph these, and then go up and turn off plot 3, plot 1, you have to press second and y equals, turn it on, and let's see what happens when we graph it. Once again, you'll have to readjust your window. But look, it says minimum is 37, your maximum 61. So I'm going to go from 35 to 65. My x scale will be 5. I'll do from -1 to 10. My y scale I'll do as 1. And let's see what happens when we graph it. Oh, this is group C. Well. That's unfortunate. It was supposed to be more symmetric. Oh, I see what happened. Do you see what happened? It didn't come up as L3. I must have not pressed it. So it's L1. Now I graph it. Oh, there we go. Now you can see it's more symmetric. And once again, my value still goes off, so I'd have to make this I have to make this higher, so I'll go to 15, and maybe I'll go by 3s. There we go. And like I said, if you want to graph this as a box and whisker, it's best to use the one that shows whether or not you have any outliers. You can see there are no outliers. And once again, if you want to do this as a normal quantile plot, you have to go over to this one, click it in, press graph, and then, like I said, use the zoom function, and that helps. In any event, like I said, I think this is really useful. I think the GeoGebra program is wonderful, especially for the split screen where you can do both. And that's it. So I hope that was useful. Enjoy, and don't just assume that your data is normally distributed. Check it out for yourself. All right. Good luck and have fun.